Hello, hi, and welcome again to another class, Mensuration. So here you can observe some figures, some solid shapes. See, what are they? We can see such things in our real life. In this chapter, we are going to learn about the solid figures and their surface areas, volumes, the combination of solids. So let us learn what is the definition of mensuration. Mensuration is a division of mathematics that studies the geometric figure calculation and its parameters such as area, length, volume, lateral surface area and etc. It outlines the principles of calculation and discusses all the essential equations and properties of various geometric shapes and figures. Mensuration is a subject of geometry. Mensuration deals with the size, region and density of different forms, both 2D means two-dimensional, and 3D means three-dimensional. Now, in this introduction to mensuration, let's think about 2D and 3D forms and discuss about them. So, let us see. Here, you can see some shapes which are in 2D, two-dimensional. So these are 3D shapes. Let us differentiate between them. So what is 2D shapes and 3D shapes? So here you can say if a shape is surrounded by three or more straight lines in a plane, then it is a 2D shape. Here in this shape, it is surrounded by number of surfaces or planes, that is in 3D shape. So these shapes, that is 2D shapes, have no depth or height. Here in 3D shapes, you can see they are also called shapes, and unlike with 2D, they have the height and depth. So they have height and depth. These shapes, that means 2D shapes, have only two dimensions. They say length or breadth. These shapes, they have dimension and they have depth, that is height, breadth and length. We can measure their area and perimeter for the two dimensional. For three dimensional, we will measure the CSA, that is curved surface area, lateral surface area or total surface area or value. So we can calculate this. So let us go through. So next here, this is important thing we must learn. We ought to learn these things. That means so what are the terms? We must learn the terms of the mensuration and their abbreviation, how we can we are denoting it, and what are the units we are going to give. So I will give explanation of two definitions. Area. So A, it is denoted with a capital A, and the area will be in meter square or centimeter square. So the area is the surface which is covered by the closed shape. Okay. So perimeter, P, it is denoted with P. It will be centimeters or meters. The measure of the continuous line along with the boundary of the given figure is called the perimeter. Similarly, the volume is denoted with V. It will be a centimeter cube or meter cube. The space occupied by 3D shape is called the volume. So CSA, curved surface area, and LSA, lateral surface area, TSA, total surface area. So these are all things just you can learn from the definition. So observing very closely to this chapter, we'll learn about all these things. And now, have you seen this? Have you seen this ever seen? Have you played with this? So this is a cube. This is a cube. So a cube has six faces of equal area, 12 edges. Edge means this is the edges, and 8 vertices. This is vertices. Okay. So it is we can clearly see from the figure, it has 6 faces of equal area, 12 edges like this, edges, and this is the vertices. So vertex, so 8 vertices will be there. So what is the lateral area for the cube? Lateral area means area of 4 walls, or you can say area of 4 walls. That is 1, 2, 3, 4 shapes. So 4 sides. So what is the area for one side? It is A into A square. So 4 times of A square, 4 times of side square, or you can say 4A square. Similarly, total surface area. Total means entire cube. That means we'll add the top and bottom. So that is 6 times top and bottom. Another 2 a squares will be added for the lateral surface area. It will be 6a square. So finally, volume. So volume is nothing but side into side into side cube. So side cubic. So you can observe. So these units are very important. Square units. So lateral surface area, because it's area. So square units. So it's a volume. So we have to denote with the cubic units. Okay. So next. So what is a net diagram? Net diagram means if you cut open with this thing, so what it will be, how it will be denoted. See this figure. So if you cut and open, it will look like this. So so this is called net diagram. That means through this we can prepare a cube. Okay, right. Next, see one example. Find the lateral and total surface area of a cube with the side 5 centimeters and also find its volume. So already we know the formulas, how to calculate the lateral surface area, total surface area and volume. So let us use the formulas. Let's say 4 times of a square. Instead of a means side. It is given as 5 centimeters. So 4 into 5 square. 5 square means 25. 4 into 5 square. 5 square is 25. 4 5 is 100. It is centimeter square. Square centimeter, square units, because area. So total surface area, 6 types of side square. That is 6 into 25. That is 150 centimeter square. Volume, side into side into side. 5 into 5 into 5. That is 125 centimeter cube. In this way, we find the lateral surface area, total surface area, and volume of the cube. Next. So next, have you seen this? This is somewhat different from cube. So have you seen this? This is a VCR. So what the shape? Have you seen a brick? So these are all shapes which are called as cuboid. So what is the difference between cube and cuboid? In cube, all the surfaces have the same area, but in cuboid, there are some side shapes are rectangular shape, and they are of different area. Okay, different surface area. Let us see what are the properties of a cuboid. A cuboid has 6 faces, 12 edges, and 8 vertices, same as cube. And what is the lateral surface area? See, if you observe this figure, so what is, so here this is called length, very long side, and this is called breadth, and this is called height. This is called a height. So lateral means area of 4 walls, 4 sides. That is 1, 2, and 3, and 4 sides. So here, what is this LH? Length into height, breadth into height. Similarly, opposite side, LH and BH. So if you calculate that, it will be 2H into L plus B. That is 2 times of LH, 2 times of BH. Finally, if you take 2H as outside common, it will be 2H into L plus B. So this is the area of 4 walls, or we can say the lateral surface area of a cuboid. So total surface area. Total surface area means we will add top and bottom. So what is the area for top and bottom? LB and another LB will be added. So it will be, the formula will be like this: 2 times of LB plus 2 times of BH plus 2 times of LH, or we can say 2 times of LB plus BH plus LH square units. So what is the volume? So volume of cuboid is nothing but length into breadth into height. So it will be LBH. Simply we'll say LBH. L is denoted as length, B breadth, H is height of cuboid. So it will be in cubic units. Now let us see the net diagram. What is the net diagram of this? See, if you cut and open out along the edges, so it will look like this. So this is the net diagram. Through this net diagram, we can prepare a cuboid. Okay, we'll see an example how what is how applicable to cuboid. So this is an example. Find the LSA, that is lateral surface area, total surface area, and volume of a cuboid of length 6 centimeters, breadth 4 centimeters, and height 3 centimeters. So lateral surface area, that is, what is the formula for that? 2H into L plus B. Here, from the given, length is 6 centimeters, L is 6 centimeters, B breadth 4 centimeters, height H equal to 3 centimeters. Substitute these values in the formula. That is 2 into 3 times of 6 plus 4, that is 6 into 10, 60 square centimeters. This is LSA. What is TSA? 2 times of LB plus BH plus LH. So if you substitute the value of L and B and H, 2 times of 6 into 4 plus 4 into 3 plus 6 into 3. So finally we'll get 2 times of 24 plus 12 plus 18 added together, 2 times of 54. So it will be 108 square centimeters. Finally, volume, very simple formula, length into breadth into height, 6 into 4 into 3. So it will be 72 cubic centimeters. So very simple problem. So these are the basics of the mensuration we ought to learn. So next one. So what have you seen this shape in your real life? So this is called cylinder. So what are its sides? You can say these sides are curved surface. So remember in the previous sessions we have seen cube and cuboid, they are plane surfaces, but here it is a curved surface. So let us learn about the properties of cylinder. Bases of cylinder will be the shape of circle. So bases here base. So base, you can say this base, top and bottom, they are in the shape of circle. You can observe clearly, and sides are curved. So base, this is radius, and this is height of the cylinder. So base radius is denoted with R, and height will be denoted with H. So what is a curved surface area? Curved surface means side, lateral surface. Here we call it as a curved because the sides are in the shape of curve. So here the formula will be the perimeter of the base into height. So perimeter of the base is 2 pi r because it's a circle. So 2 pi r into height, 2 pi r h. This is the curved surface area formula, square units. So total surface area, that means if you add the top and bottom areas. So what is the top area? It is a circle, and bottom also circle. So you can say pi r square, another pi r square. So 2 times of pi r square will be added to the curved surface area. If you take 2 pi r as common, 2 pi r into r plus h. So this is the area, that is total surface area formula. So volume is nothing but base area into height, so it means base area pi r square into height, so pi r square h, cubic units. So this is the formula to calculate the volume of the cuboid. Okay, so next, what is the net diagram of the cuboid? That means if you cut and open, so what you will observe means, see here, this will be if you cut open, the top and bottom are circles, and the entire curved surface will be a rectangle. Okay, it will become a rectangle. And next we'll see one example for this. So what is the can you calculate CSA and TSA and volume of the cylinder? The base radius 4 centimeters and height 7 centimeters. So using the formula, let us first write what is given. R, radius 4 centimeters, height 7 centimeters, and curved surface 2 pi r h. 2 into pi means 22 by 7 into radius 4 into 7. Calculation will be 176. Similarly, total surface area, that is 2 pi r h plus 2 pi r, substitute in this. So 2 into pi, 22 by 7 into r plus h. So the calculation will be like this, 276.57 square centimeters. So volume, base area into height, that is pi r square into h, pi r square into h, 4 into 4 into h. It will be 352 cubic centimeters. So next, very good. Have you seen this ever? It look like a joker cap. So it is ice cream cone. Some example for this, and this is called as cone. So cone means here very important thing we have to observe, that it has one vertices, curved surface, and base is circle. So here to find this is slant height. This is called slant height, and from top to the midpoint of the, that is center of the circle, if you draw one line perpendicularly, this is called height of the cone. height of the cone is different from the slant height. Slant height means this one. You can understand from the figure. Okay. So base of the cone will be in shape of circle, sides are curved, and radius of the bases are height is h and slant height is denoted with L. So this slant height is L, original height is h, and the base radius is r. So curved surface area, it is nothing but pi r L, pi r L, and the total surface area is nothing but pi r L, that is curved surface area plus base area, that is pi r L plus pi r square, that is pi r into r plus L, and the volume is nothing but 1 by 3 pi r square h. So here I want to tell one matter that, so if you take one cylinder, one cone of the same height and same radius, so if you calculate if you pour or if you calculate and compare the volumes, so the volume of the cone will be 1/3 of the volume of the cylinder. So the volume of the cylinder is pi r square h. So here the volume of the cone will be 1/3 of pi r square h cubic units. Okay, so and one more thing here, because of this perpendicularness, that means the height is perpendicular to the radius and this is slant height, it will form a right angle triangle. Hence L square is equals to r square plus h square, that is lateral height square equal to radius square plus height square. Okay, so now we'll see how the net diagram of the cone will be. If you cut and open it, you can observe that the base will be a circle and the remaining curved area will be a sector. Next, the one example from the for the cone. So find the CSA of the cone whose slant height is 14 centimeters and the base radius is 5 centimeters. Also find the total surface area and its volume. So directly substituting the values in the formula, that is pi RL, pi 22 by 7, R L means 14. So if you calculate 7 2 is 14 and the entire thing will be 220 square centimeters. Total surface area, that means if you add 1 pi r square to the curved surface area, it will be total surface area. That means pi r into r plus L. Pi r, instead of r I am substituting 5 into r. R plus L means 14 plus 5. So here it will be if you calculate the entire thing, it will be 298.57 square centimeters. To find the height, so to calculate the volume, we must need the value of height h. So we know that h is equal to square root of L square minus r square. Substitute the L value and r value, we will get it approximately 13.076. So if you substitute 1 by 3 pi, that means 22 by 7 r square into h value. So I'm sorry, here we have to substitute this 13 point, approximately I have put this one 14. So it will be 366.67 cubic units. Next, we will play this. We play with this. You know what is this? It's a ball shape, isn't it? So we'll call it as a sphere. Our Earth is the best example for sphere. A sphere is a three-dimensional round-shaped, round-shaped object. Unlike the other three-dimensional shapes, the sphere does not have any vertices. It didn't have any vertices. All the points on the surface of this sphere are equidistant from the center. So here we will only one area will be there, that is surface area. That is 4 times of pi r square. 4 times of pi r square, and volume will be 4 by 3 pi r cubic units. So let us take one example. Let us take one example for the sphere. Find the surface area and volume of the sphere. The diameter 14 centimeters. The diameter of the sphere is 14 centimeters. So the radius will be 4. So here diameter is given. So we have to calculate 14 by 2. That is half of the diameter, 7 centimeters radius. Substitute the value of radius in this 4 into pi 22 by 7 into 7 to 7. So it will be 616 square units. So volume 4 by 3 pi r cube. So it will be 4312 cubic units. So very simple, just substitute the value of r in the formula. So this one, have you seen this? What we call it? This igloo. So it is in the shape of a hemisphere. That means exactly if you cut the solid, that is solid sphere into half, you will get a hemisphere. A hemisphere is a three-dimensional geometric shape, that is half of a sphere with one side flat. You can see here one side flat and other side is a circular ball. One side is flat. So what is the curved surface area? If you take entire sphere, it will be 4 pi r square. If you take half of the sphere, so it will be 2 pi r square. Only curved surface area. And total surface area, that means entire means curved surface area plus base area. That means curved 2 pi r square, and this is a circle. So it is pi r square. And it will be 3 pi r square. This is very important thing. Total surface area of a hemisphere is 3 pi r square. And volume. Volume is half of entire sphere, that is volume of full sphere is 4 by 3 pi r cube. Volume of hemisphere is 2 by 3 pi r cube, because this half in its entire volume. So igloo is the somewhat we can which is look like a hemisphere. So many shapes, so many examples are there from your real life. You can observe from your real life. Okay, so let us take an example. Find the curved surface area, total surface area, and the volume of the hemisphere with the radius 3.5 centimeters. So if you observe the formula, from the formula directly, if you substitute the 2 pi r square, that is curved surface area. Curved means only top, that is 2 into 22 by 7 into 3.5. Calculate it, 77 square centimeters. So total surface area, that means this entire surface area plus base area. So base area is pi r square. So 2 pi r square plus pi r square, 3 times of pi r square. Substitute the value of r in the, instead of r you substitute 3.5, you will get 115.5 square centimeters. Volume 2 by 3 pi r cube, 2 by 3 of pi r cube. So it will be like this. Okay, 89.833 cubic centimeters. And in the next video, we are going to learn about the combination of solids. In this video, we have learned about the basics of the mensuration. In the next video, we'll learn much more. Thank you for watching my video. Like it, share it, comment it, and subscribe my channel. Don't forget to subscribe my channel. Yours, Lanka Raghavendra.